So now let's look at broadcasting. I start with a motivating example to explain why broadcasting is useful. Then I will compare it to matrix algebra and we see why it's different. And finally I explain formally what broadcasting is and how it works. So think of an example where we have a number of houses on a road. Yeah, so just as a simple So we have 10 houses on a row, and the thing that I'm interested in is I want to have a table with the distance between each of these houses. So the first house is at position 0, the next house is at position 1, then at position 2, etc. So the difference, the distance between these two is 1, the difference between 1 and 6 is 5, etc. So I want to quickly generate a table which gives me these differences. And then broadcasting is actually going to be very useful. So I'm going to define a vector with these addresses. So I'm going to use numpy arrange for that. And then I'm going to say x0 is going to be x, all these numbers from 0 to 9, including 9. And we're going to use this new axis. Then I'm going to have x1, which is also equal to x, but now first the new axis, and then all these points. So when you run this, make sure to check what is, for instance, the shape of x0, and compare it to the shape of x1. Now the thing that I'm going to be using here is because this is one-dimensional, so I just need to take the absolute value. I don't need to take, in 2 dimensions you would take the square root and then the differences in the x and y coordinates squared. But here it's to get the distance, it's just this. And it immediately gives me this table where I can see that the distance between position 0 and 0 is actually 0. The distance between position 1 and 1 is also 0, etc. So the whole diagonal, the main diagonal are all zeros. And then the difference between position 0 and 3 is actually 3. The distance between position 2 and 4 is 2, etc. Yeah, so by choosing the dimensions of my variables x0 and x1 in a clever way, I can very quickly generate this table of differences between points on this line. And this is one of the advantages of broadcasting, that we can actually do this. So now let's look a bit more formally. So let's first think about a matrix. So we have a matrix A, and the first row consists of 1 and 2, and the second row consists of 3 and 4. And then B is also a numpy array, but it consists of 10 and 20. And just to be clear, I'm going to reshape this as 2 rows and 1 column. So it's a column vector if you like. And then I can do matrix multiplication. And if you do the matrix multiplication, the answer is a new vector with 2 rows and 1 column, and the values are 50 and 110. Yeah, so that would be standard matrix multiplication. So just to be sure that we're all on the same page. So my matrices would look like this. Oops. So if we multiply them, I can view it like this. So when we do matrix multiplication, I multiply this 1 here by the 10 over here. So that gives me 10. Then I multiply the 2 here with the 20 down here. So it gives me 40. So when I add them together, I get 50. And similarly here, I get 3 times 10 plus 4 times 20. So that's 110. Yeah, so that's standard matrix multiplication. And in order to get the matrix multiplication, so just to be sure, I use the following. Yeah, so the matrix is 2 by 2, and I multiply it by a vector b that is 2 by 1. Yeah, so you can think of it like this. So that basically means that I'm going to get a vector which is 2 by 1. Yeah, and the matrix multiplication works because I have a 2 here and I have a 2 here. Yeah, that makes sure that I can actually multiply these matrices. So one thing I cannot do is add these two matrices. Yeah, so if I use matrix algebra and I try to add a matrix which is 2 by 2 and one which is 2 by 1, that will not work. But actually, in Python I can add these things. And here I'm using for the first time broadcasting. So how are these two added? Basically what Python does, it broadcasts this column next to the one that we already have, so I can actually visualize that. By writing it like this, so let me do it like this. Yeah, so Python sees that I have here a 2 by 2 matrix and I have here a 2 by 1 matrix, so actually I need another column, and then it duplicates or it broadcasts the column that I already have. And now when I add it together, I'm simply adding it pointwise. So I'm adding 1 to 10, which gives me 11. I add 2 to 10, which gives me 12. 3 to 20, which gives me 23. And 4 and 20, which gives 24. Yeah, so in this way I can actually add matrices, although that would not be defined in terms of matrix algebra. So now if I actually do the multiplication, I don't get matrix multiplication, but I get the same idea that I multiply the matrix that I have element-wise by the column that I have, and I have to duplicate the column to make that possible. Yeah, so now we don't add, but we multiply, so I get 1 times 10, which is 10. I get 2 times this 10 over here, which is 20. 3 times this 20, which is 60, and 80. Yeah, which is exactly what I have over here. So what we see is that multiplication and addition are defined in a different way than they are with matrix algebra. And therefore it's also the case that some things that we cannot, some multiplications or additions that we cannot do with matrix algebra, we actually can do in Python with broadcasting. So just to give you a couple more examples that you can play with, there are more examples in the notebook where it's asked, to check whether things are possible or not. So I'm going to define 3 variables, reshape, A, B, and C. So let me copy this and do it again. So this is going to be B, this is going to be C. Here I'm going to have 6, and I'm going to use the shape here 1 by 5, and here we're going to use 1 by 6. So simply play around. Try to see whether you can, for instance, have matrix multiplication like this, B times A, and you can do A times B, so you can check this one, you can look at A times b and see what the results are. Yeah, so the thing that we're interested in here is the fact that if I try to do b times b, I get an error. And actually Python is quite explicit by I get the error, because it says, when you try to multiply a matrix which is n by k with another matrix, that matrix needs to be k by m. Yeah, because these two dimensions need to be the same. But in our case, when you look at b, I can look at the shape of b, it's 1 by 5. So I'm trying to multiply a matrix that is 1 by 5 with a matrix that is 1 by 5. And that simply doesn't work. It's not possible. But again, here I can do b times b, and that actually works. And the way it works is I'm doing it element-wise. So I get the first element of b times the first element of b, which is 0 times 0, which is 0. Then I get 1 times 1, which is 1, 2 times 2, 3 times 3, etc. Yeah, but it doesn't mean that anything goes. So if I try, for instance, to multiply b with c, I actually get an error. Yeah, because it says it cannot broadcast the vector b, which has shape 1 by 5, with the vector c, which has a shape 1 by 6. Yeah, so to see what is possible and what's not possible, let me give you an idea of what the rules are with broadcasting. So the rules of broadcasting. So the way Python looks at it is it starts at the last dimension. Of the two tensors. And it checks whether these two dimensions are compatible. And they are compatible if either they are equal, so let's say they are both 5, or when they're not equal, at least one of them is actually 1. Yeah, so when you try to multiply two vectors, like we did over here, so I had a 1 by 5 and a 1 by 6, then Python starts at the last dimension and it compares 6 to 5. These two are not equal. But also the second requirement is not satisfied because none of them is equal to 1. Yeah, so then it will throw an error. However, if this is satisfied, it will move to the next dimension, so it moves to the left, and then it will actually do the exact same check. So it checks whether that dimension then, whether it's equal, and whether one of them is 1. Yeah, so to give a final example here, so we define a vector y, which we reshape to 1, 2, 3, 4, and 5, and have a vector z, which is equal to numpy range 12, and we reshape it to 3 by 4. So now we try to do y times z, and it will give an error. And it gives an error because it cannot broadcast y and z, which have shape 1, 2, 3, 4, 5, and 3 and 4. Yeah, so the way it works, it starts at the end, so it compares the 4 to the 5 over here. These two are not equal, but neither of them is equal to 1, and therefore it throws an error. So what we can do is make sure that the final comparison here is between a 1 and a 5, because then Python is going to be able to do it. So I'm going to add a dimension using new axis here, and I'm going to run it, and now Python is able to actually do this. So now it can multiply these things. let me just quickly show why that's the case. So print Y shape, print Z shape, oops. Oh, sorry. I want to print the shape of this thing. Yeah, so now when Python tries to broadcast these two, it starts at the end. It compares 5 to 1. They are not equal, but one of these is actually 1. So it goes ahead. It moves to the next dimension. These are equal, 4 and 4. So that's fine. These are equal, 3 and 3. And here, there is of course no dimension here. So rather 1 and 2, because this is a 5-dimensional tensor and this is only a 3-dimensional tensor. But then Python itself will add the ones here, so we don't actually need to do that ourselves. Yeah, so therefore these two vectors can be broadcasted in such a way that you can multiply them, add them together, etc.